Hi, welcome to Meets Rod Shop. I'm Jason. Today we're going to continue with our 351 Cleveland build. As you saw in the previous installment, I had the crank installed, torqued, assembly lube all put on there. So the crank's in there, we're ready to go. I filed some rings. I have the rings sitting here numbered 1 through 8. We're about to start putting them on the pistons so we can get the pistons installed, get them plastic gauged, checked out, and bolted down. So let's continue. All right, you see here I've got a piston on the rod. I believe this is the number 2 piston. Let me read it here. It is the number 2. It's marked on the big end here, and I'll bring you in closer. Good thing to mention, when you tear down an engine, before you tear it down, on both the rod cap and the actual main part of the rod, on a single side, don't want to do it on opposite sides. You want to stamp the number of the cylinder it came out of, whether it's a 4-cylinder, 8-cylinder, 2-cylinder, whatever. You want to make sure and mark it so that the rod cap goes back together with the correct rod. These are milled together and that they're also facing the same way, because if you'll notice there's a chamfer on one side of that rod, which should, if I'm correct, the chamfer should go against the counterweight side. So you always want to make sure that's installed properly. Plus that way you know when you balance it, you'll know which cylinder to put them into and everything else. So make sure to mark these if they're not already marked. I think Ford later on your late model stuff, I think Ford automatically marks them from the factory. I could be incorrect on that, but I know all the late model stuff I've taken apart has been marked. But I'll bring you in here. Let me grab a different one. This one doesn't show up very well, but that is the number 2. I've got the number 6 rod and piston here. You can see it a little bit better. I'm going to go ahead and approach the camera, and maybe you can get your eyes in here and you can see it. But if you'll look right here on both the cap and the main rod part of the rod, you can see where it's stamped 6 in there. So that's a good thing to do. Make sure you stamp, like I said, both of them on one side. So let's go ahead and we'll start getting some rings in here. Before we put the rings on the pistons, let's go ahead and talk a little bit about it. These rings I chose for this build are the plasma moly rings. Cast rings aren't used too much anymore in a normal application. Most everybody's either running the total gapless plasma mollies or something along those lines. I chose these, to be honest with you, just because plasma moly is a good replacement ring. They're cheap, they last well, they don't dig into the cylinders like the old cast rings do. And I'm putting them on a hyper-eutectic, I believe it's a Silverlight piston. These are a flat top piston. They're 30 thousandths over. They're cut like most of your Clevelands are for your valve reliefs. To be 100% honest, the reason I went with these is because they're cheap. This build, as I mentioned in my previous film on this, it's a stock build. This is a stock 351 Cleveland. It's going into a pretty mint condition 70 Mach 1. So I went with a local racing manufacturer or store, major store down there in Georgia. I went with their brand, which I believe is Hastings, plasma moly rings, and we're going to stick them on these Silverlight hyper-eutectic pistons. End gap I've talked before was 26 thousandths on the top ring, 18 thousandths on the secondary ring, and then the oil ring is just 15 thousandths. That does depend on your application and your engine. You know, if you're running a forged piston or a cast piston, it will require a different ring gap, and it all depends on street versus street strip versus nitrous versus blower setups. You'll see that the ring end gap will need to be changed according to what you're running. To get a little off subject, compared to this engine, I've got a 410 cubic inch small block Ford engine that I use in a road course car that runs forged pistons, and I planned on spraying it with a little bit of nitrous, so you actually have to dial in a little bit more end gap than what is typically called for. So if you look at your instruction sheet here, they'll tell you on a hyper-eutectic piston, for street and street strip, you want 65 thousandths, excuse me, it's bore times 65 thousandths for the top ring. Circle, track, drag racing, they want 7 thousandths as the multiplier. Forced induction up to 15 pounds, 85 thousandths. Forced induction over 15 pounds, 9 thousandths. Nitrous up to 200 is 85 thousandths, and nitrous over 200, they want 9 thousandths as the multiplier for your end gap on your ring. So as you see, and that all changes, especially compared to your forged pistons, cast pistons, it's a little bit less, but your hyper-eutectic, you always want a little bit more end gap. I actually broke a piston ring land on the first engine I ever put together for my road course car. It was just a standard 351 Windsor that I ran some Keith Black hyper-eutectic pistons in there, and I didn't put enough end gap in the rings and actually cracked one of the ring lands, beating on the car a little bit, which it was my fault. But so you always dial a little bit more. You always dial a little bit more end gap into these hyper-eutectic pistons. You don't want to go too much, of course, because then you start getting blow by and other issues. But follow your ring manufacturer's ring gap suggestions. Make sure it's based on what you plan on doing on the engine. If you know you might possibly run nitrous, go ahead and dial it in there. You don't want to have to tear the engine back down to add more ring gap later. It's just not feasible to do that. You know, I like to stick an engine into a car once, be done with it. I don't like pulling them in and out. As much as I enjoy working on cars, that gets a little bit tedious. So let's go ahead and we're gonna move on. I'll grab a piston and we'll correspond it with the correct number of rings that I've already gapped, and I'll show you how to put them on there. All right, so I've got the number 6 piston and rod here, and I've got it marked on the end cap there and on the rod. So I've got the wavy ring for the oil control. Let's go ahead and let's pop that on there. Those go in pretty simple. Just snap them in place there, as you can see. Good to go. Let's grab the retaining rings for this. We'll get them put on. All right, here we go. So let's, again, here's the retaining ring for that. They do make a tool for this. I do not own it. I've just always walked them on by hand, never had a problem. There you go. So that's installed. Let's get the secondary ring. All right, I don't know that you'll be able to see it or not, but if you look, there is a little indentation on top of that ring that tells you that is the top. This is for the secondary ring. So you'll go ahead, slip it into there. You'll pry it up a little bit. Be careful not to break it. Don't force these. You can break these. Just don't scratch the piston. Snap it in place. There you go. She's on. Let's go ahead and get the top ring. All right, here's the top ring. So I've got the oil control ring installed. I've got the secondary ring installed. Here's the top ring. On these top rings, I filed them. I filed the sharp edges off from where I actually opened up the end gap a little bit. These are perfectly square. There is no top or bottom on these, but make sure and check your specific ring because there could be a top and bottom. And again, we want to clock these so where the end gaps aren't lined up with each other. So you just spin it on there like that, as you can see, and then walk it on. So now if you notice, right now I've got the end gap together. So if you can see, you see how the end gap's together? You want to make sure and clock these differently so that you don't have that. I'll just clock them about 120 degrees out. So right now I've got the secondary ring gap there, and if you look, I've got the top ring gap over here. This will move around when the engine's running, so it's not that big of a deal, but on initial start, you just want to make sure they're clocked out. So that's it. I'm not going to walk you through the other ones. You've seen one now. Process is the same. I'll bring you back in when we start shoving slugs into the cylinders. All right, we got the rings on the pistons. I've actually already installed 2 in the block. I had the neighbor running some lawn equipment, so I didn't record that, but sounds like they're starting up again. So I guess I'll have to apologize for the sound, but we'll go ahead and bring you in on this piston here. I've already installed half the rod bearing, and I got some rubber hose here. I'll bring you in here. So just stick some rubber hose over the rod bolts so that you don't scratch your cylinder wall. And if you notice, the half the rod bearing is installed. There's also, if you remember that from the first video, there's a little chamfer inside the rod here where the bearing will snap into. And one thing you want to make sure, if you notice here, if you look, the bearing is actually offset in the rod. And what that allows for, that should be the arrow or the dot. A lot of pistons will have a notch, a dot, or these actually have an arrow pointing to the front of the engine. You want to make sure that chamfer is on the correct side of your crank because the counterbalance has a chamfer there, and if this is on the other side, you'll chew up your bearings. So you want to make sure that chamfer is on the right side, which it is on this one. So, all right, let's talk about ring compressors. I like the solid one-piece ring compressors. You can buy them. I think this one's from Summit Racing. It's a 4-inch 30 thousandths overbore solid ring compressor. It's tapered, so you don't have the old ratcheting band strap that goes around. I mean, they work, but they're definitely not my favorite. So what I do on every single piston, I'll clean this with WD-40 just to make sure it slides smooth. So let's go ahead and do that. So let's spray a little WD in there. Usually, whatever you want, penetrating fluid, PB Blast, or if you want to spend the money on the Seafoam, that's fine too. But so you go ahead, take your piston, slide it down into your ring compressor. This is the number 3 we're going to do right now. So you got your piston in your ring compressor. It's ready to go. You want to make sure that your rod journal is centered down in the hole. That way it's not off on an angle. Won't go in properly. Be gentle, slide it in there. You know, pretend it's your first date. Be real nice. You want to hold that ring compressor solid to the top of the block. Grab your hammer, and you know, I've got a piston hammer here. You don't have to have one of these. You can use a stick, you know, something that won't mar the surface. And just drive it on home until she clicks. And that's that. Now I'll turn it over, and we'll go ahead. We're going to put the plastic gauge on there, throw the other bearing cap on with the other half of the bearing, tighten it down, and we'll check it out. So you got the bearing cap here, and you got the bearing. If you notice, there's a little kick out in the bearing. That just snaps right in place. That little chamfer that's in the rod cap there. So she's good to go. I've got the plastic gauge installed. I want to make sure the chamfer's on the right side. It is. We'll go ahead and we'll place this cap in, slide it down. Take your ARP lube, since I'm using ARP rod bolts, which they are 50 foot-pounds on this. Just put a little bit on the cap surface where the bolt rides at, or excuse me, the nut. Put some on the thread. Get them finger tight. You want to make sure that your rod is pressed up against your counterbalance. Then go ahead and crank it down. What I like to do again is I split it. So this is 50 foot-pounds is what it has to be to, so I go 25, 25, and then take it on up to 50. So again, you just want a smooth motion, tighten it on up. Till it's even. There's 25. There's 25, and we're going to take it on up to 50. Again, you want a smooth torquing motion. I switch out. Again, I don't use my torque wrench to back off bolts. It's just personal preference. Go ahead, take your hammer, knock the piston down a little bit. She'll release the cap for you. Now, I don't know what's going on here, but let's get this cap off here. Come on. You know you want to. Oh, come on. There we go. And it looks like she's going to be good. We'll go ahead and we'll get our plastic gauge measuring stick here. And for this engine, she's within tolerance. All right, so go ahead and scrape off your plastic gauge remnants on your crank. Like I say, I use my little plastic scraper here. I just shave it on off. Clean it up, make sure she's nice and clean. Clean it off the bearing cap without marring your surface. I always spray it down with a little brake clean. I'll go out and buy a case of brake clean every engine I build just to be safe. Take my lint-free cloth, spray a little brake clean on there, and I'll clean the rod journal where the plastic gauge was. Make sure nothing gets down in the crank. She's good and clean. Rod bearing's good and clean. So I'll take my assembly lube, put a liberal coating on it. Again, you want to make sure the chamfer's lined up properly. Stick her back down on there. Pull the piston up tight. Go ahead, put a little bit more moly on there if it looks like it needs it. And then tighten her back up to 50 foot-pounds. She'll be good to go. Then you move on to the other side. I do suggest Some guys will work down one side of the engine and then work down the other. What I do is I like to work cylinders opposite. That way the ones that are on the same rod journal, that way when I'm turning the crank over, I don't have assembly lube squeezing out into the other half of the rod journal where there's no rod. So I always try to work opposite cylinders on a V8. You do what you want, but that's what I do. All right, let's go ahead and get it torqued up here, and then we'll get the rest of these installed, and I'll bring you in and tell you what the next step is. All right, we're back. We got all the pistons installed into the block. We got everything torqued. We got pre-assembly lube stuck together. Now I'm going to go ahead and install an oil pump here. On these early model Mustang Ford pumps, they just have a thread-in style pickup. I do not use the tape on these. What I use is I actually use the sealer. It comes in a tube. It's actually in a jug. The problem is I find the Teflon tape can get in here and lock it up, but the other stuff won't. So I went ahead and I installed the pickup already. What you'll need to do is you take your oil pump shaft here. Again, I'm running an ARP setup on this. It's just a stronger oil pump shaft. So what you'll do is you take this and you set it down in there in the hole washer at the top, so that let me drive that in there a little bit more, so that way the washer stops it from coming out when you pull the distributor. I have had in Ford engines before where you pull the distributor out and you hear tink tink tink, and the distributor drive shaft / oil pump shaft drops down into the pan, and now you're having to drop the pan to get the shaft out. So always make sure on these Fords that you run that lock washer that stops the shaft from coming out. So after you put the shaft in there, you go ahead and take your oil pump, get your gasket, place that down on the pump, make sure it's in the right place. So you set that down on there. Then you want your drive shaft to go into the pump properly. Set it down on there, line it up, and then what I like to do is I take my bolts and I run grade 5 or grade 8 bolts on my oil pumps. I run a lock washer, and it's a little redundant, but I'll run a little blue Loctite in each one. You know, you do not want these things coming out. So line up your gasket, line up your pump, start threading your bolt in there. If you can find the hole. There we go. I think there's a joke there, but this is a clean channel for the most part, so we'll keep that joke to ourselves. A little Loctite on there. Go ahead and get that started. Then I'll go ahead and grab a socket, torque it down, and we're good to go on the oil pump. Next, we're going to go ahead and install a camshaft. I'm just reusing the one that was in the car originally. It's a Crowder. I'll be honest, I don't remember what the grind number was, but it's good for about 1,500 to 6,000, 6,200, I want to say, which, like I said, that's right where I'm going to be using this car the most. But we're going to go ahead, we're going to lube it up, and then you want to take your time sliding it in. So make sure you get lots of lube on all your lifter lobes and on your cam bearing guides, and then just slowly drive her in there. You know, and as you pick it up, just kind of, you know, smear the goob on there. Take your time. That way you don't nick any of your lobes, you don't nick any of your camshaft bearings. Let me go ahead and get the rest of the goop here. Get a lot on the distributor drive gear as well. Just smear it on there. Like I said, you can't have enough, you know. Let me set that down. We'll go ahead and drive it the rest of the way in. Take your time. Like I said, you're not in a hurry. There we go. She's in. So all we got to do is get the camshaft retaining plate and bolt. Go ahead and get that installed. All right, we've now got the cam installed in the block. I've got to put the retaining plate on there, which I've taken some brake clean to it. I've got the bolts here for it there. It's pretty self-explanatory. Just make sure which side goes towards the block. On these Clevelands, the oil holes, the oil galleys are actually machined in each side, so it doesn't really matter which way you put it on this thing. So just go ahead and get it, start your bolts, tighten them down. Not sure what the torque is on this, but yeah, I'm just going to be honest with you. Other than like head bolts, mains, and then of course flex plate bolts or flywheel bolts, I just use the old German torque, which is good and tight. You look it up, it's not a bad idea if you go ahead and torque it right to the right torque, but hey, I just do it this way. Click. That's my pre-calibrated elbow clicking. Click. All right. Now comes the timing set. So you can go ahead and put the timing set on there, which I've got this one here. Again, I think it's a Summit Racing brand. It's nothing special. I'm just going to put it in straight up. And what straight up means is that I'm not advancing or retarding the timing at all. You can do that. I think it's 4 degrees. And you got to look and see. I believe I'll read the instructions here, but it'll tell you which one of the key ways to use to either retard it or advance it or put it straight up. But I'll look at that real quick. And we'll figure out how to do it. So the three, yeah, here's so the factory is the 0. So make sure you got this lined up properly. So what you're gonna find, bring you in close here. So if you look, there's a dot right here on this tooth. And then I'm gonna go ahead and use the 0 right here. Oops, I'll make sure I put that on properly. So that should line up, and I'm 1 tooth off. So right there, so I'll go ahead and slip this onto the cam and the crankshaft like this. Make sure they line up properly and we'll be good to go. So I gotta turn the cam so that it lines up. And then turn the crank. All right. So I've got the camshaft lined up and I've got the crank lined up. Let's go ahead and slip this on. All right, so we went ahead and I've got the timing chain loosely installed. What I mean by loosely installed is I've not installed the bolt that holds the sprocket to the camshaft yet. On these Clevelands, there is an oil slinger. You'll find on some older engines, there's a slinger that goes on the front of the snout of the crank. And what that does is it picks up oil and slings it up on the timing chain so it doesn't wear. Make sure and install that. It's real easy. All it does is just slips on over the crank and lines up with the keyway. So we'll go ahead and just slip that on there. I'll get a socket here and drive it on there, but that's it. All right, I've got the fuel pump eccentric that goes on the front of the camshaft to retain the camshaft. I'll bring you in and show you this. Not all cars run this. You don't need to run this unless you're running a mechanical fuel pump. But it's just around, it's offset with the bolt hole. So this holds the camshaft in, and then your fuel pump arm actually will come in and ride on this. And as this spins around on the camshaft, it runs that fuel pump lever, and that's what actually pumps fuel. So we're going to go ahead, we're going to put that on the front of the camshaft, and then once I got my son helping me today, Danny, he's going to take off all the old gasket material off the timing cover. So once he gets that done, I'll bring you in there and we'll show you how putting the timing cover on. Then we'll probably, if I had to guess, probably throw the lifters in, throw the heads on there, and then throw the oil pan on last. I always put the oil pan on last. That way if I drop something down in the engine, it's easy to get to. So we'll go ahead and knock that out and bring you in. All right, we got the timing chain bolted down. We put the fuel pump eccentric on there. It's good to go. My son went ahead and cleaned up the timing chain cover, cleaned up the oil pan, and we're gonna press this front seal in for the harmonic balance where it goes on the timing chain. So one thing I want to show you before we press the seal in here is a lot of these seals that you'll run, they have an inner spring like axle seals and whatnot. So you've got a spring that's around the inside of this lip, and before you start hammering on that, that spring will pop out a lot of times if you just whack away on it. So what I like to do is I take a little petrolatum or Vaseline, and I'll pack Vaseline in a couple spots around the inside of the seal, and that will keep that spring retained inside here. That way when you smack it with a hammer and a socket, it doesn't go anywhere. So I just wanted to show you that real quick. Just a neat little trick. All right, now that we're moving on, we're going to go ahead and I've got the seal pressed into the timing cover here. Just dropped the gasket for the water pump, but I'm going to go ahead and I'm going to seal up the gasket for the timing cover here. I'm gonna place that on, and then we'll install the water pump at the same time. I'm not gonna go into too many details on that, to be honest with you, just because it's pretty simple. You know, watch your threaded holes into the water pump jacket area, because there is some, you'll have to put some PTFE sealer on there because there is some bolts that go into the water jacket. So you want to make sure that you're not having weepage coming out of those. So go ahead, seal up your bolt holes that go into the water jacket, like the 3 that are right around the water pump. They go in there around each inlet and outlet. So, but that's pretty simple. I'm not going to bother showing you that. We'll just go ahead and bolt it on, and then we'll bring you in afterwards. All right. All right, we got the water pump bolted up. We've got the timing cover bolted up. We're gonna go ahead and press on. I got lifters soaking right now, getting all the air out of them. We're gonna go ahead and press on with installing some heads. Let's talk about head gaskets a little bit. On this engine, I am gonna be running a multi-layered steel gasket. It's 80 thousandths compressed thickness. It is a little thick for this engine, so it is gonna lower compression ratio a little bit, not much. But the reason I'm running these gaskets is because on the engine that come out of the car, unknown to me when I bought the car, it had 12.5 to 1 compression. The car originally had a lot of overheating issues. It wouldn't run right. It was pinging real bad. Turned out it had a lot of issues. It had 46 degrees total timing. It was 12.5 to 1 compression, amongst some other machining issues. The heads weren't machined properly, whoever did the rebuild on the car originally. So I've switched blocks. That's why this engine is getting built now. So I'm going to reuse my MLS head gaskets from the last combination, which they tell you never reuse head gaskets. The only time you can reuse them is when you're running a multi-layered steel gasket and that you clean them properly, which I have with these. So instead of putting a composite gasket on there, which those work fine, and they probably work fine in this combination, to be honest with you, but I'm just going to stick with the multi-layered steel gaskets to 100%, to be honest with you, because I paid a lot of money for them, and there's no reason for me to go out and buy different head gaskets when these will work just fine. So I want to talk to you a little bit about head dowels. I know all your engines, they have a locating dowel that press into the block, and then the head gasket fits over that, and then your head actually fits on top of that. Make sure you're using these dowels. I, believe it or not, have known people that have tried to put heads on without them, and they end up having a lot of issues. So they're just small little rolled piece of steel that usually goes in the lower right hand, left hand, forward, aft corners of the block, and then your gasket snaps down over it, and then the heads get set on top of that, and you bolt it down. So what I'll do now is I've got the dowels out because the engine just came back from the machine shop, so they always pull them. So I'm gonna go ahead and put new dowels in there, and then we'll go ahead and throw the gaskets on there and set the heads on, and then I'll show you the torquing sequence. One thing I want to mention when you're doing these cylinder heads on these Clevelands is the crossover passage. That back of the block does not have a crossover passage from head to head, so you want to make sure on your head gaskets, if you look here, you can see there's a crossover passage for coolant at the front, but not at the back. It's blocked off. So you got the passage at the front, not at the back. You want to make sure when you put your gaskets on there that you have the proper hole in the right place. Otherwise, you put that hole at the back of the block instead of the front, you'll overheat the cylinder head real quick. So make sure when you're placing them that you do put them in the proper orientation. Otherwise, you will end up having cooling issues. And seeing as that's the whole purpose I took this engine apart on, I definitely don't want to deal with that again. So I got the gaskets sitting here. We're going to go ahead and I'll pick up the heads and we'll stick them on here, and I'll bring you back in to show you the torque sequence. All right, I've got both cylinder heads balanced up on the top of the block, on top of the cylinders there. They're sitting on the dowels. I've got 2 head bolts just threaded in just to hold them in place for right now, but I wanted to bring in and show you the difference between a 4-barrel head, which is what this engine is, and a 2-barrel 351 Cleveland head. You hear a lot of people talking about intake size. Man, I'm gonna tell you what, there's a huge difference between a 4-barrel and a 2-barrel head in these 351 Cleveland. So I'm gonna bring you in here so you can look at the size difference in this. All right, so what you have here is this is your standard 4-barrel head. You can see the size of the intake ports here are pretty massive. You know, these 4-barrel 351 Clevelands are well known for flowing a lot of air, a high RPM, high revving engine, and you can see just why they like them RPMs, because of the size of the intake on there. And then over here on the table, I've got this is a 2-barrel head, so you can see the size difference. I mean, it's puny compared to that 4-barrel head, but I just wanted you to see that there. So there's a 4-barrel opening and a 2-barrel opening. All right, so we're gonna go ahead and I'm gonna get you put back up on the camera stand there, and we'll go ahead and go through torque sequence. All right, we've got the cylinder heads sitting up on top of the cylinders. We've got the head bolts just down snug. We've got them lubed. Everything's ready to go. I got my torque wrench set to 35 foot-pounds, and we're gonna work from inside out in small circles, basically. So again, you want a nice smooth torque pattern. You don't wanna jerk it. You don't wanna stop and start, stop and start. So there's 35, go into the next lower middle, over, cross, back over, cross, this ensures a nice even clamping force. Then we're going to take this up from 35, we're going to go on up to 70, that's foot-pounds. All right, now we're going to take it on up to 100. All right, we're gonna go back through, just double check. All right, she's double checked. So that's it. So the passenger side cylinder head, she's torqued down. All I got to do is the driver's side, and then we'll probably throw the oil pan on, and then we're going to throw a little bit of coating on her. She's brand new block, so I want to make sure she's the old Ford blue. So we'll go ahead, we'll tape her off. We'll tape off the valley. We'll paint her up, tape off the water pump. It's actually, this water pump's a high flow water pump that's already been powder coated clear. So we don't want to paint that up, you know, keep it somewhat pretty. So, but that's what we'll do. We'll go ahead and torque up the other head, and then we'll go ahead and install the oil pan. Thanks. All right, we've got the cylinder heads torqued on. We've got the water pump on. We've got the timing cover on, the timing pointer on. What we're gonna do is we're gonna go ahead and clean up the oil pan. We're gonna get that bolted on next, and then we're gonna block off our oil pressure port, which is back here on the top of the back of the block. We're gonna block our distributor hole, and then we're going to go ahead and paint this up. I got the dipstick hole I got to plug, of course, the water temperature hole, which is in the front right of the block here. So we'll go ahead and we're going to acetone the pan. It's an older oil pan. I think it's original to the car, so it's pretty nasty. We're going to clean that up with a wire wheel and some acetone. We'll bolt that up, and then we'll tape off all of our intake ports, tape off everything else that we need to stop from getting paint on there. And we're going to go ahead and put a coat of paint on this thing, make it nice and pretty. So hopefully this thing will run all right. You know, it's like they say, if it looks good, hopefully it runs good. Chrome don't win. I don't know, something like that. At least there's no chrome. All right, we got the oil pan cleaned. We're getting ready to put it on there. Before we bolt it down all the way, you want to check your oil pump pickup clearance to the bottom of the pan. You don't want it too far away, and you definitely don't want it to where when it's drawing oil that it sucks to the bottom of the pan, and then you basically, you're not drawing any oil and you tear everything up. What they say is 3/8 of an inch to 1/2 of an inch distance between the bottom of the pickup and the bottom of the pan. So there's several ways of doing it. You could either take a straight edge, put it across the pickup, and then measure down to the oil rail, and then measure from your oil rail in your pan down to the bottom of the pan. I just do it real simple. I take a little ball of modeling clay, and I'll stick it, don't put it directly on your pickup. You want to put a piece of tape down so you're not smashing modeling clay into your pickup. And then you just set the pan down on top of it, and you then pull the pan off, and you'll measure and see how far that modeling clay squishes down. You can use modeling clay. I've seen guys use sticks of butter. You could even use fresh dog poo if you want. Of course, I do suggest if you're going to use the dog poo version, make sure it's your own dog, because your neighbors probably won't want you walking around in their yard picking up dog poo. Or maybe they do, but they look kind of weird sticking in your pocket. So stick with the modeling clay. That usually makes it easy. So I've got the modeling clay on there. I got the tape on there. We're going to set the pan down. I can feel it smushing. So the pan's down, and remember, you're going to also give up a little clearance, a little more clearance for your pan gasket that's going to go on there. So the pan went down. I felt that stick. We're looking good. So you go ahead and you take your ruler, your trusty steel rule, and you measure it. And we're just under 1/2 of an inch of clearance, so we're good on that. So what I can do now is I can go ahead and I can get my pan gasket. I could put that down there. You always put a little dab of silicone in each corner around the front and rear of the pan where it comes down and meets the actual pan rail off of the rear main or off the timing cover. That's typically where they tend to leak at. And then just torque it down evenly. These Cleveland pans, they don't have a secondary rail. Some of the newer small block Fords, they will have secondary oil pan rails that go in there and help distribute the load. I don't know of anybody that manufactures that for these Clevelands, but it would be nice. But I'll be honest with you, these Clevelands they're kind of out of date here in the U.S. I know the Australian folks, you guys use them a lot, but in the U.S. there's not too many Clevelands running around. It's kind of getting hard to find parts for these. And I understand it, you know, the new small block, well, I say new small block Fords, they quit making them, what, in 95, 96, whatever it was. You know, with the advances we have in the cylinder heads and stroker engines and stuff like that, these Clevelands have kind of fell to the wayside, and I can understand why. You know, I'm definitely more of a standard small block Ford guy. This is my first Cleveland I've been messing with, but so let's go ahead. We're going to get that oil pan installed, and we'll press on from there. One thing I wanted to mention too before we actually bolt this pan down is, number one, don't forget to take your tape and your dog poo or your modeling clay off your pickup. That's important. You want to make sure your pickup's level as well. But on these Clevelands, I wanted to add into it here on the rear main cap for your rear main seal. They don't make rope seals for these anymore. I don't think you can order them. All they have now is the neoprene seals. And on the main cap, which I probably should have told you this when we were putting this together, there is a pin that sticks out of the actual number 5 main cap that is made to stick into that rope rear main seal, and it stops it from spinning. So when you're putting these engines together nowadays, since you're not using a rope seal anymore, you have to drive that pin out. It will not drive into the neoprene seal, and you will end up having leaks and problems. So when you put the new oil pan on with the new setup, you're gonna have to plug that hole that you pulled that pin out of. Just put a little plug of sealer, just a little dab over there, and that will stop that hole from leaking if it ever gets past that rear main seal. But I'll try and bring you in here real close so I can show you what I'm talking about. If you look right here, you can just see that little hole where the pin originally was, and the pin sticks down into this rear main seal. So you'll just take a drift pin or something and you'll drive that pin through, and then it's an open hole now that goes down into that rear main seal. So just go ahead and put a little dab of silicone on there when you put your oil pan on. You're going to be putting a little bit of sealer. Let me show you here. You know, you're going to be, when you put the the sealer in this hole, you're also going to be putting sealer down in these corners here on both sides of this rear main cap and then on the front main as well. So I just wanted to show you that in case you were wondering. That's where that little pin is. So that's it. So we're ready to go ahead and throw this oil pan on here. I'm gonna put a little, like I said, sealer in the corners there, put a little seal on that old pinhole, and we'll drop this oil pan on there. And then we'll get ready to throw some paint on it. All right, we've got the sealer put in the corners of the pan. We've got the neoprene end gaskets on there. We've got the composite gaskets for the rail on there. We've got the oil pan set down on there. This is gonna be the last time you're gonna do anything inside the engine, so you wanna look in there, double check everything, make sure you didn't drop anything in there, make sure cylinder walls still look clean, no dirt, no debris, because remember, cleanliness is major on new engines. So we go ahead and place it on there, and you gotta be careful with these oil pans. You don't wanna over torque them. You'll start squeezing the gasket out. Now this is a composite gasket. It's not like the old cork style, which really squeezes out, but still, if I'm correct, I believe this is like 9 to 11 foot-pounds on the torque for the pan rail, which equates to like I don't have a foot-pound wrench that goes that low, so I use my inch-pound wrench if I use it. I typically don't, but that's like 105 to 110 inch-pounds if you're looking to convert. But just use your best judgment on here. Torque them down, torque them snug. Don't you know, Jean-Claude Van Damme them and just really wreck it in there. Just be smart about it. But we're gonna go ahead, we're gonna, again, in a torque sequence, start in the middle of the pan, either work your way around in small circles or work your way angle, you know, across on your way out to the ends of the pan. Torque it down, and then we'll be good to go. So I'll go ahead, I'm gonna put the bolts in here, we'll torque them down, and then we'll throw some paint on this thing. All right, we've got the oil pan bolted down. I used lock washers on all the bolts here. I got a little bit of sealer squeeze out, so I know I'm good. She's nice and torqued down. I'm gonna go ahead, I'm gonna grab my my Swedish nut lathe here, and we're gonna take this crank bolt out so that I can get the balancer in there. You want to put the balancer on, of course, before you paint it, so you're not getting oil on your crank snout or inside the engine going through where your seal is on the front of your timing cover. So let's go ahead, we'll get this crank bolt out. I got my balancer here. So here's my balancer. A little tip, what I like to do, it's saved me before. Actually, I've got a 71 Dodge Dart I just ran through this problem with. I had the balancer slip. You know, you've got the counterweight on the outside of the balancer, then you got your hub. Unless it's like an SFI approved or a fluid dampener or something like that, you're gonna have an elastomer, like a rubber elastomer in here that counterweight is pressed onto. You can have it where that counterweight will actually spin on your elastomer and on your hub, and then when you go to check your timing, you think it's 10 degrees before top dead center. Turns out it's 30, or it's after. And that's one of the problems I had with that Dart. It was running really bad after I changed the distributor on it, and it seemed like it wanted to stall and backfire, and it was acting like timing. So I throw the timing light on there, and no, that's saying it's 12 degrees before top dead center, so it can't be timing, right? Yeah, well, luckily, what I always do is I paint a stripe across the hub, the elastomer, and that outer ring. That way, when you look, you can see if that paint is off, you know that your hub has spun a little bit. And that's what I noticed on that Dart. I looked down and I saw that the paint lines didn't match up, so sure enough, I had spun the balancer on there. But what you do is you'll take a little bit of oil, a little WD-40 something, and you'll rub it around the hub here before you push it on or press it on there. And a lot of guys will just use the crank bolt to drive these on here. I'll be honest with you, I'm guilty of doing that at times, but here recently I went out and I bought a harmonic balancer installer tool, and that's the way to go. That way you're not stripping out threads in your crank, because you just spent a lot of money at the machine shop getting that crank turned. I'd hate to have to tear the engine back apart to take the crank in to get that fixed for the threads. So go ahead, use your harmonic balancer tool installer, and you'll be good to go. Here's my balancer installer tool. This is just a cheap kit I bought off that Rainforest place online. I want to say I spent 25-30 bucks on it. It's not much, but I'll show you how it works. Go ahead, open it up, and you'll find your crank adapter, which I believe on this Ford, I want to say it's 3/16 by 16. I may be wrong. Let's see here. I am wrong. is 5/8 by 18. All right. So what you'll do is take this bolt, you'll stick that in there, and then you'll thread in your adapter. Just thread it in until it gets tight, you know, make it snug. And then you'll take this tool along with the nut. You'll thread that nut on there, and there's a little washer, as you can see here. This little like bearing washer, whatever you want to call it, is used to press down on that crank. So you'll go ahead and put it together. I've already got the balancer pressed on here. So you go in, you'll thread this bad boy in there. Well, all right, we're going to go ahead and do what I just told you not to do, because this cheap OTC tool, yeah, it's junk. We'll just we'll throw that in the garbage. The little washer that's supposed to go on there with the ball bearing so it's nice and smooth motion just fell apart, and all the ball bearings went flying everywhere. So that cheap tool is garbage. Don't buy that thing. Maybe you'll have better luck with it, but we're going to go ahead and do exactly what I just told you not to do, and that's drive the harmonic balancer onto the crank with the crank bolt. So wish me luck. Let's hope this thing doesn't strip out the crank. Seems to be driving on pretty easy. We'll go ahead and we'll torque that down before we put the engine in the car. I'll go ahead and I got a flex plate tool that I bolt on the back of the flex plate to hold my crank solid while I'm tightening the flex plate, stuff like that. So we'll put that flex plate tool, holding tool on there. When we get this off the engine stand, we'll torque this harmonic balancer down tight. I think I'm also going to go ahead and probably upgrade to an ARP harmonic balancer bolt. It's not required, but it's always just a little bit of nice insurance on that. So now that we got the harmonic balancer temp installed, well, I guess it's technically fully installed, but not torqued down yet. But now that we've got that in there, we'll go ahead and we'll get this engine painted. Let me get some tape on some areas that doesn't need any paint, and then I'll show you how that works. I'm definitely no Michelangelo or Leonardo or any other of the Ninja Turtles. So I guess Bob Ross? No, I guess that's not. I'm not Bob Ross either, so not a very good painter, but I'll show you what I can do. All right, we've got everything taped off. We're ready to put a little color on this thing. This is a 1970 Mach 1 engine, so it should be the old Ford blue. They do have two different Ford blue colors. They got regular Ford blue, which is the new stuff, and they've got the old Ford blue stuff. You probably can't tell on camera what the difference is between the two, but we're going to use the old Ford blue. Not really because it's the right color, mostly because I've got 2 cans of this, and I've only got 1 can of the regular Ford blue. So that's why smart shoppers go with the 2-can one. So let's go ahead and we'll get it shaken up. All right, before you start painting, you know, you want to put some kind of respirator on, preferably not M95 or N95, whatever these are. But you know, I'll be honest with you, I'm feeling lazy today, so I don't feel like getting my respirator out. So do as I say, don't do as I do, or do, or I don't know. All right, here we go. Little test spray. You know, and before you start painting, you want to make sure you got everything covered up that you don't want to overspray on in your garage. You could roll the engine outside, but I'm lazy, and I have a gravel driveway, so I don't want to do that anyway. So, all right, everything's wiped off. We're ready to spray. Just put a nice light coat on everything. You know, you don't want to get too crazy yet. You want something, you want it to tack up a little bit. It's a nice light first coat. I'm not worried about the exhaust ports because they're going up into the engine. I'm not going to spray up into it. I will probably tape them off when I flip it over and do the oil pan. But for now, I'm just going to put a nice light coat on everything. Not trying to get it to coat all in one shot. You don't want that. You just want to give it something to stick to. And again, I'm not spraying into the exhaust ports. I'm just spraying across them. And really, I want to coat this nice fresh iron block so it's not going to coat a rust. which it's gonna eventually it'll rust anyway. You know, this paint doesn't stay forever. Again, nice light, even coat. Again, I'm no Christopher Columbus or Michelangelo or I don't know who's those painter guys. All right. All right, so that's the first coat. We'll let this sit for a couple of minutes. We'll let it flash over. Then we'll come back and we'll spray a little bit more. I think I'm gonna step outside, get me a nice cold beverage. I don't think I have any in my garage fridge. That's an issue. I think that should be an OSHA violation in my world. But we'll go ahead and get me a nice cool beverage out of the fridge, and we'll let this tack up for a minute. All right, we let it dry for a couple of minutes. Let's go ahead and we're gonna go ahead and put the last final heavy coat on there, fog it on there real good. Putting it on, laying it on pretty thick here. Really get the oil pan good. It's going to take a beating underneath the car. Hopefully not from the rods coming out from the inside, but hey, you never know. All right, well, that's it. We've got her painted up. We're going to go ahead and let it dry before we take off all the tape and everything. I'll post another video later of the intake going on. It'll probably be in the car at that point. I don't know if I'll actually show the engine going in the car. You know, I can't believe there's that many people looking at a video for a 351 Cleveland going into a 70 Mach 1. There's not really anything too exciting about that. Just getting a room to drop it in there, match everything up, bolt it up. So that's it for this video series. I will show a video of it running in the car, probably first initial startup, tuning on the carb a little bit, setting timing, you know, watching your temp, putting oil in there, what kind of oil to use and everything else. But that's it for now. I want to thank you for taking the time to watch this video. Drop any comments down in the bottom there, what you have, what you like, what you don't like, any suggestions. I'm sure there's probably a lot. You professional engine builders, I doubt you're going to watch this video, but if you do, you know, tell me how bad it was. Anyway, thank you. Remember, keep your stick on the ice and your head up.